Alrighty, time to talk about trigonometry, right triangle trig using sine, cosine, tangent. Number one thing before I start anything, make sure you're looking at right triangles. Number two, make sure your calculator is in degree mode to do this stuff. And number three, one thing you probably always wondered is who would win in a fight. This character from Frozen, I think that's Elsa, I think her name is, and this ice horse, whatever that is. So at the end, stay tuned, see who wins. It's going to be fun. I think him. Alright, so anyway, three things we're going to go over. How to write the ratios, how to solve for missing sides, and how to solve for missing angles. Those are the three major things you need to do, and they all build off of one major concept. Don't worry about this yet. We'll talk about this in a second. I started writing some stuff before. I should have probably gone through this as I did the video, but here we go. Here we are. But everything, about 75% of what you're doing builds off of this right here that you've probably seen before. It's the sine of an angle. We call it theta. That's a Greek letter theta. Sine of theta equals opposite over hypotenuse. Cosine of theta equals adjacent over hypotenuse. And tangent of theta equals, sorry, I missed an equal sign, opposite over adjacent. You'll typically see SOHCAHTOA, SOHCAHTOA. A lot of people use that device to help them memorize these three ratios. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. Just reminding you that these are sides, and these thetas or A's or B's are angles. These are angles, okay? So, first example, how to do ratios. Sorry if I'm going too fast. But I give you a triangle, has to be a right triangle. Triangle A, B, C, it's a right triangle. Sides are H, G, and K. I've taken the liberty of labeling G as my hypotenuse because it's across from the right angle. Hypotenuse is always across from the right angle. So these opposite and adjacent sides can change depending on if I'm looking at angle A or angle B, but the hypotenuse will always be across from the right angle. So the side that's not touching the right angle is your hypotenuse. Now the opposite can be a little trickier. I did sine first. That's going to be opposite over hypotenuse. According to angle A, which is right here, the opposite side will be the side that is furthest from A. And the furthest side from A is going to be K. So for angle A, K is the opposite side. So sine would be K over G, or opposite over hypotenuse. Alright, taken from right there. So opposite over hypotenuse from angle A. Now the other two angles I've decided to go with are B for cosine and tangent. So these are going to be B, and based off of angle B, G is still the hypotenuse. The opposite side, the side furthest from angle B, will be H. So in this situation, K is the adjacent. That's why I wrote that down before. I probably shouldn't have. It probably makes it a little confusing, but for angle B, K is the adjacent side. Adjacent just means it's one of the two sides of the angle that's touching angle B. We can't use G because it's a hypotenuse, so our alternative is K. So this is adjacent. For angle B, adjacent, opposite, hypotenuse. So when I say cosine, it's adjacent first, so that's going to be the K again, and the hypotenuse will be G, adjacent over hypotenuse. Tangent is going to be opposite over adjacent. We're looking at angle B now, so the opposite side is the furthest, which is side H. The adjacent side is the closest, that is not the hypotenuse, which in this case will be K. So that's how you write ratios. Sometimes they're letters, sometimes there's numbers like 3, 4, 5 here, and in that case you just write a 3 over 4 or whatever it may be. But there are your ratios. That's probably one of the easier things. The second thing is finding a missing side or sides. Alright? And these triangles are not to scale. I'm making them up. But they have to be right triangles. And I'm too lazy to measure them out, so I will just tell you they're a right triangle. Because, why not? And we'll say A, B, C. And we'll say I want to find the measure of that side, X. And all I know is that this side is 10. And then this side is going to be 40 degrees. Or this angle, I should say. So I cannot use Pythagorean theorem because I need two sides to do it. but I can use this information. And what you're going to want to do is identify what you have. This is going to be the hypotenuse. You need to identify opposite, adjacent, hypotenuse. From 40 degrees, the furthest side from 40 is going to be x. We're going to call that the opposite. That means this side will be the adjacent if we're talking about angle B. Angle A, these actually change. But we're going to go stick with angle B because that's what we know. Then you're going to pick the appropriate one of those three that actually uses hypotenuse, because we have the 10, and the opposite, because that's what we want to know. So we want the function that uses O and H. And that, from these three choices, is going to be SOH. So we're going to use sine. And we always put the angle next to the trig function. And we write equals. In this case, it's going to be opposite over hypotenuse. So opposite is x over hypotenuse is 10. And all you're going to do from that case, as long as the x is not inside the angle, we can just turn this into a fraction, and we're going to cross multiply the fraction. 1 times x is x. 10 times sine of 40 is 10 sine 40. And you are simply going to put that into your calculator just like it looks. I'm literally going to put that into my calculator. And when I put that in, I get x is approximately equal to 6.428. Usually you're going to have to round to a certain amount of decimals, usually at least one. We're going to round to tenths place, so let's go hundredths just to show you real quick. I want to write this decimal place, so I'm not just going to put a 2 in there. I'm going to look at the number after, which is 8, and 8 is bigger than 5, or bigger than 4, I should say. So we're going to write 3. We're going to round the 2 up to 3. Sorry, it took me way too long to figure that one out, but we're going to write 6.43 units. All right, and that takes care of that problem. Now I'm going to write a little star here, and I'm going to give you something that you should be aware of. Sometimes you'll write a situation like this, and we could have done angle A. I'm not even going to go there. I'm just going to make it real simple. We can write a situation. This is not part of this problem. I just want to show you something. Sine of 40, and what if it were 10 over x? Well, the math works pretty much the same. This is not the answer to this problem. This is totally separate. Just a little heads up. And we still cross multiply. 1 times 10 equals x times sine of 40. And to solve that, we want to get x by itself by dividing both sides by the sine of 40. So it works a little bit different than that. So if it starts like this, it's pretty simple. If it looks like this, it's almost the same, except we're going to be doing this at the end instead of this. And like I said, that's just putting that in your calculator and just making sure you take your time, and you are going to get 15.56 units. Alright, and that's how you find a missing side. And then lastly, we want to be able to find a missing angle. And that's pretty simple. Everything's going to work almost identically the same, except this time we're not going to be we're going to be missing an angle. I'm going to call that angle x, and I'm going to give two sides of the triangle. I'm going to say, let's say 10 here and 15 there. And I want to find out what that is. And we can do this with sine, cosine, tangent. Actually, yeah. So what we're going to do is we're going to, again, identify what you have. This is your hypotenuse. This one is going to be your opposite. And this one is your adjacent. All right, so we pick what we know. We know 15. We don't know what x is, but we're going to have to use it. And we also know 10. So we're going to use the formula that uses O and H. So again, we're using sine. This could happen for sine, cosine, or tangent. Nothing changes. We're going to write our formula, sine of the angle. This time we don't know it, so we call it x, equals the opposite over the hypotenuse. All right? Now, normally we'd cross multiply. Do not cross multiply here. You don't want to cross multiply. No cross multiplying. Okay, do not cross multiply here. What you're going to do instead is on your calculator, well, depending on what you're looking at, usually most calculators have a sine button, and then right above it, same thing with cosine tangent, is a little -1 power. That's the inverse. And all that does is it finds the angle. So if I want to find the angle coming out of this ratio, all I'm going to do is write inverse, and you're going to put the 10 over 15 inside here. So you're basically going to switch these two spots, and you're going to get your answer that way. When I put this in my calculator, I come out with an answer of 41.8 degrees. And there you have it. So that's how you do pretty much everything with sine, cosine, tangent. You'll notice that all of these problems involve you identifying opposite, adjacent, hypotenuse, and determining which of these three that you're going to use. And then you simply write it out, write it out, write it out, and you just have to do the math from there. And that's how you do it. And I know the real reason you're still probably all here is you want to know who's going to win this contest. So why not? Let's do it. Let's zoom out a little bit so we can get a little perspective. So on the count of 3, we're going to shoot these guys at each other. 1, 2, 3. That was very anticlimactic because they both stayed alive. So we're going to try one more time. One of them will survive. One of them will fail. And like I called in the beginning, Elsa's a loser. Ice Horse wins. You guys have a great night, and I will see you tomorrow.